are we are going to use them to do the math. So if you would put them back together in a nice little stick of Unix cubes, and as everybody's getting in here, go ahead and just lay those down on your desk, and you will use them in a minute to help you with some math. Once we get everybody situated. Give us just a minute. Everybody go ahead and lay your Unifix cube down. Thank you, ladies, for doing what I asked you to do. Y'all need some stuff. The board. Do you do screen mirroring to show things on the board? So it's just you go to the Apple. So I would just sit that. Perfect. So I'll take pictures and you.
It will be better if I push my first and then you push that.
I love how all of you are using Unifix cubes as tools now and letting them lay there on your desk. I appreciate you all following directions. Okay, is everybody ready? Awesome. Okay. Well, good morning again. Does everybody remember what my name is? Right. So I'm going to be teaching your math lesson today. We've already talked about your tools and how you have a couple of sheets of paper. One sheet of paper has number paths on it that you might use to solve the problem. And I also gave you the task in front of you in case it's hard to see on the screen. Okay. So here's what I need. All eyes on me. So let's talk about what we're learning today. After you guys have been learning different strategies to solve problems. So today we're learning to analyze some equations to determine the strategy being used. If you're analyzing something, try to tell your neighbor, what does it mean to analyze something? What does that mean? Exactly. All right, come back together. Could you tell us what you think analyze means?
Think about.
To think about, right? Did anybody have something else they think analyze means besides think about? Yeah. Oh, you think so? Well, you'll be looking at how numbers are put together or taken apart. But he's exactly right that you were thinking about these equations in order to figure out how they were solved. Because you guys know about strategies to solve, don't you? To solve problems? I hear you've been learning about that all year. Different strategies to solve problems. So you're going to be looking at two equations and trying to figure out who solved it correctly. Okay? And you're going to know you've learned it when you can explain. So when I'm coming around and asking you questions, you're going to be able to explain, but also model the strategy. If I'm asking you to model, how would you model something? What are some things you would do to model? Yes. There you go. Make it and show it. Couldn't have said it better myself. You can model using the number paths. You can draw arrows and lines and write on your number paths. You also can use your tools, your Unifix cubes, as tools to show it as well. Is everybody cool what we're doing today?
Yeah.
So we're going to analyze these equations, and you're going to figure out what strategy is being used and why, if it works or not. Okay, and you'll know you mastered our success criteria for today if you can explain the strategy and tell why it works. So at your desk, you also have this sheet. It says this. I'm going to read it to you. Are you ready? Sarah solved 15 minus 9 by adding 9 plus 1 to get 10, then 10 plus 5 to get 15, and said the answer is 6. Kevin solved 15 minus 9 by subtracting 15 minus 5 and got 10, and then he did 10 minus 4 to get 6. What I need you and your partner to work on is to determine who is correct and why. And remember, our success criteria, you have to model on your paper or with your cubes and be able to explain who's right and why. Are you ready? Awesome. You are getting to work, and I'll be coming around and asking you all some questions. And so I'm going to let you get started, and I'll be around in just a second. So what are y'all thinking? What you? Okay, so you're trying Sarah's strategy to see if it works. Yeah, so what are you starting with to solve, to do Sarah's strategy? So what did she start with? What did Sarah do first?
She wants to
Okay, can you show that using your number pad or with your cubes? How Sarah, or you can get your pencil out and draw as part of our success criteria list of models. So you're welcome to draw on this and show what Sarah's thinking, or you can use your cubes. So I want you guys to think about how could you show what Sarah's thinking and if she's right or not using the number pad. Okay, we'll be back check on you. You guys get started back here? What do you think? What do you think is right? Have y'all talked about that yet? Your sheet right here, buddy. What do you think? Y'all thought about Sarah and Kevin? You see Kevin's right? You think Kevin's right? Why do you think? So you think Sarah's wrong? Why do you think she's wrong?
Kevin is so
Okay.
Can you give me?
Okay, so could you show me and prove to me why Sarah is wrong using the number line or number pad? You tell me, where did Sarah start? She solved 15 minus 9 by adding 9 plus 1 equals 10. How do you show that on your number line? There's 9. And what did she add? One more. So have to use your pencil and show how she added one more. Use your pencil to show me how she started at 9. Yeah, she did it, didn't she? So she added 1. So then what did she say she did after she added 1? What did she say she did next? After she added more, then she added 5 more. Could you show how to add 5 more? Okay, so I'm wondering. So you're saying that she said she got the answer of 6, y'all? Where's the answer of 6? The answer. Oh, there's a 6, but where she's saying she got 6. What are you doing? Did you see what she just did? She said this is 6. How did she get 6?
6. There's 6 of them. Okay, no.
What did she just do when she did this?
So now we got 15. Here you go. Here's your cube.
Tell her what you just did. I did that. Right, 6 of them. So I'm wondering. You said Sarah's wrong. You still think Sarah's wrong? So we were trying to find the difference between 0.9 and 16. So how is her fault different from Kevin's? You said Kevin was right. I want you and your partner to talk about Kevin's strategy and use this line to show Kevin. What do you think you could do to this line to show Kevin? Okay, so look at Kevin's solution. And I want y'all to talk about what that's like. Okay, I'll be back to Kevin's. You know he's right. Why do you know he's right? Okay, but what? Okay, tell me how he's subtracting. Remember, part of our success criteria is to model and explain. So you have to model why Kevin's right. Okay. Okay, so what problem was Kevin solving first? So he did 15 minus 9. He started at 15 and did what? Could you show that on this number pad? Where did he start and where did he go on his pattern? Okay. Okay, but what did he subtract first? He didn't go all the way to 6 first, did he? Okay, could you show that like the jump, the way he went? So he subtracted 5. Could you put 5 there so we make sure we know what happened? I want to ask you a question. Why did he stop here? He wasn't subtracting 5 there. Why did he stop there? Oh, number 10. We like that friendly 10, huh? And then how many did he subtract after that? One more. Can you show that? So I have a question. Now, where's the 9 that he subtracted? Where's the 9? Oh, look at that little line. So that shows he took off the 9. And why did he say he took off 5 first and then 4? Okay, so you guys are sure that Kevin is correct. What I wondered is, can you use this line up here to try to find out if Sarah's correct? I want you to do what she did. Use your line and jump around and think about, is she right? Where's her 6? All right, guys, we got it. Who's right? Kevin or Sarah? Okay, so you show me that remember part of our success criteria is the model and explain. Can you explain? Do we have one? No.
So we okay, so
Yeah, go ahead. It's not fitting on the line. Hey, tell me what you just made.
then I'm
Is this what happened? So then what did we have to do first?
So we're grab
There's 5. And then what do you take?
now it's at 17.
So it said you took off 5, but that's not the reason.
So
Yeah, where's the 10? In your model, where's the 10? Here's the 10. So that's 15. You took off 5. Why did you just took off 5 instead of taking off the whole 9? Stop at 10.
Good. So now let's put 2 more.
Y'all learned about 10? Yeah.
No, what did it equal? Good.
Problem.
So now
So we took off 5 here. Now what's he going to take off next? He has to take off the whole 9. He only took off part of it.
now what is 15 times 2?
So, and I'm going to leave that here.
Good. So now
Okay.
we're gonna add up all the way to
Oh, why did what's that correct? You didn't think so at first, did you? Why did you why did you show it? Because he ended up with 6, right? So when he took 15 off, he was left with 6. Do you think Sarah's right? You don't? Here's what I want y'all to work on. See your number pad here. I want you to talk about what Sarah did. She started at 9 and added 1. I want to see if you can figure out how Sarah came up with 6, because you said he's right here. Use the number pad to do some arrows moving on the number pad to tell me how Sarah is wrong. Okay? All right, come back to the minute. All right, guys, y'all got it figured out over here? Oh, timer. We have about 2 minutes left. Go ahead. Who you can try? You think it's good? Okay, how do you grade it? Remember, part of our success criteria is to model and explain. Hang on just a second for our last 2 minutes. Remember, our success criteria was to model and explain. Look at your paper. Have you used the number pad to model who's right and who's wrong? Have you used your cubes to model? Remember, they're tools, not toys. If you haven't met the success criteria. So you need to be modeling. Okay, if I can get to you, I'm going to be over there in just a minute. How can you prove it? Remember, how can you prove it using this line? Where did Sarah start?
She started at 15.
Okay, so Sarah solved 15 minus 9 by adding 9 plus 1 to get 10. How can you show that on this line? Can you show that with your pencil, how she walked on the line? Do that. And I want you to figure out how she came up with 6 and whether she's right. Did that come up with 6? Let's talk to you two groups together. So what you said, you can do it either way. What'd y'all say?
Took away no. Oh, wow.
Okay. 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 You guys are saying they can do it either way, right? Oh, but I don't see your model on there, so I need you to convince this group. Because they're saying Sarah's wrong, that you can't do it because you're adding 9 plus 1. Can y'all help convince them that Sarah's right? What would you tell them? Why do you think Sarah's right?
This because it equals to
She did get 6, but where is her 6? Oh, we're almost coming back together, about another minute. How can you prove it's 6? Can you look at your number line to prove to me? See, you think Kevin's right because he subtracted everything. Can you show on your number pass, both of you real quick before we start sharing and discussing? How could Sarah have gotten 6 if she started at 9? Use the path to show what she did to see where her 6 is, okay? What y'all come up with? These two groups. Did y'all come up with an answer? Who's right? Only Sarah? Kevin's not right? Or did y'all check Kevin yet? Okay, is he right or not?
It's either Kevin or it's
So which one? You got it. Either they're both right or none of them are right, or one of them. The other answer is 6. Can you show us what Sarah did? What did Sarah start with? Here, right here. So Sarah started by adding 9 plus 1. And then can you show that on the path to see if she ends up with 6 like Kevin did? Can you show Kevin that he got 6? Can you show Sarah? Can you show that? Take your pencil and show me on the path. Did y'all come up with it on the path? Oh, look at your answers here. Tell me about why you did all this hopping around.
So if it's
Okay, but I don't see 6 here. Where's the 6? No, in her answer, this is what she did. Where's her 6? Oh, what do you think? So she started at 9, she went to 10, and then she went here, and she got 6, but I don't see 6. Where's the 6? Look at her, look at the line. Where's the 6? So you're saying for this one, it's easy, it's right there, isn't it? But this one, where's the 6? How much did she jump here? Can you put a 1 above that? How much did she jump here?
Yeah.
From 10 to 5? I mean 10 to 15, how much did she jump? How much is this? From here to here. The total is 6, yes, but from 10 to 15 is how much? 5. Yeah, put that 5 on there. Let's see. Did y'all come up with it? Do you think they're both right still? No? Okay, so let's come back together and let's share and discuss some of your solutions. So if you will, put the Unifix cubes down and your pencils down, and everybody turn this way. So if your back's to the board, go ahead and turn your chair so you can see the board. For us to talk about. So what do you think? Who was right? Stand up if you think Sarah was right. Couple people, stand up if you think Kevin was right. Stand up if you think both of them were right. Ah, so we have some disagreement. I love a good math fight. Are you ready to have a good math fight? Yeah. Okay. So here's what we're gonna do. I'm gonna put up a solution and we're going to talk about it. Wait, what? Why can't I see? Because I don't have my glasses on. Hold please. All right, so I want to put this one up first if I can get it. Maybe. There we go. So I want y'all to look at this model. Remember, part of our success criteria today was first we we're learning to analyze strategies or analyze equations to see what strategies used. Remember, you were looking to see what strategy was used, and then we were trying to model and explain who was right. So I want you to look at these unifix cubes, and you see how they're broken here, and then they're broken here, and then they're here. I wonder which strategy was being modeled here. Is this Kevin's or is this Sarah's? And how do you know? Try to talk to your partner. What do you see happening here? Is this Kevin's or Sarah's, and how do you know? Okay. Kevin's or Sarah's on the board? Oh, 6 4 9. Whose strategy has 6 4 9? Sarah, she did 9 plus 1 about 10, and then 10 plus 9. And Kevin, he said, 9 plus 5, he had 5. Then he did 10, not 4, and got 6. You see those numbers up there? Right, what do you think? Whose strategy is modeled up here? Sarah. Kevin. Could you explain why you think this is Kevin's? You don't mind explaining? Give me your group. Yeah.
The reason why we think it's Kevin's is because Kevin had more parts than.
He had more. Oh, he did have more parts maybe than Sarah. When Kevin started, he had how many was his whole? He started with how many? 15. 15. Y'all see 15?
Yes.
Oh, you do? Where do you see 15? The whole. The whole, right? So if I circle this whole thing, do we have our whole?
Yeah.
Yeah. So he had a whole of 15. And so what were his parts? What did he do first? Y'all see the 5 he took off?
Yeah.
Yeah, right here. You see the 5? He took that off and they broke it over here, right? Then what did he take off? The 4, because what did that leave him, by the way? When we here, it left him with 10. And then he took off the 4, which took off those parts, and that left him with 6. So he has his whole of 15, and he took off 2 parts. Can you take off 2 parts? No, you can't. He just did. Or he could have took off the whole 9. Here's what I want to know. Why do you think Kevin took off 5 and 4 in 2 different parts? Why didn't he take off the whole 9 at one time? Try to talk to your neighbor. Why did he take off the whole 9 at one time?
So if you go to 10 and then you think now what are you doing?
Okay, so again, why did Kevin not just take off the whole 9? What did y'all talk about? Make a friendly 10. Did y'all talk about that?
Yeah.
I heard you've been learning about friendly 10s this year. So Kevin was using his strategy. So y'all are analyzing the strategy and telling me why it works. So if we agree that Kevin was right, he was left with 6. He removed that. So several of us were saying Sarah. So wait, I want to look at, upside down. Let me flip it. To show this in a different way on the number path, because most of you used your number paths to model. Yeah, so we can see it here on the number path. what Kevin was thinking. Does this show the same thing as the cubes? Do we see the 5 he took off and the 4 he took off? So what I want to know is where's the answer? Where's the answer to Kevin's question? Trying to tell your neighbor, where's the answer? And how do you know that's the answer? Where's the answer to Kevin's problem? Oh, there. So it's where he landed on the line. Is that what you're telling me? Okay, let's come back. Where's the answer? Where's the difference in 15 minus 9? Say that again. 6. So when he was at 15, he took some hops, didn't he? He hopped to 10 because it was friendly, like our friend told us. Then he hopped to 4, and then look where his answer is. Right here where he landed. So some of us were saying that not Kevin, what's her name? Sarah is not right. So if she's not right, we want to look at hers and improve. Remember, we're analyzing strategies and explaining why they're right or wrong today, right? So we want to look at hers and think about why hers isn't right if it's not. Okay? So let me get over to a model of her strategy. Hold on. It's right here. I found it. Okay, so I want you to look at this model of what Sarah did. Pull it up. Y'all see that? So I want you to talk about, look at what Sarah did on your paper that's in front of you. How does this model show what Sarah did? Where do you see her hops? Where did she start? Where did she land? And where's the answer? Talk to your partner about what's on the board. What do you think? Where'd she start? So let's look here at our sheet. Where does it say? Put your feet up. Where does it say that Sarah started? Sarah solved 15 minus 9 by adding 9 plus 1 to get 10. What does that show? Does that show 9 plus 1? Look at it. You see it? You see a 9 plus 1? What do you think? You all see it? You do? Can you show her, tell her where the 9 plus 1 is? Okay, let's come back together. So talk to me. Does this show Sarah's? What did Sarah do first? She added 1. Remember, look at your sheet. It said she solved. Back on. She solved 15 minus 9 by first adding something, right? Where did she add? So it's kind of hard to tell if this line was going forwards or backwards, isn't it? But we can put a little arrow on it right here, which I just need that away. I'll get it in eventually. That's time we're over. So they could have done this little arrow, the 9 plus 10, or 9 plus 1 to get 10. Y'all agree with that? Yeah. And then what did Sarah do after she did that? She added 5. And where did she land? 15. So 15 is her answer, right? Yes. Because, well, a minute ago, y'all told me where we land is the answer. Is that the answer? No. Uh-oh, another math fight going on. I hear people saying this is not the answer. If it's not the answer, what is the answer? Turn and talk to your neighbor. Where's the answer? And how do you know? Oops. It's been away. Okay, let's come back together. Who can explain this to me? Because I hear some people in disagreement. They're saying, some of us said the answer was here, and then I'm like, no, that's not the answer. The answer's somewhere else. Where's the answer? Oh, this is the answer. She was finding the distance between 15 and 9. So the distance between 15 and 9 is 6. But wait, why did she stop at 10 when she hopped the first time?
Because to make a 10 and then because it could be easier.
Yeah, be easier. You guys are like, I'm about to be a 3rd grader. You make 10s. It's fun and easy, right? So she did her jumping. So Kevin took them off and then landed at 6. And Sarah, she jumped up. I want you to turn and talk. Why do you think Sarah chose to jump up to get to 15 to find the difference rather than to go backwards? Why do you think she did that? Turn and talk to neighbors. Why do you think she did that? Okay, let's come back together. So I have both of the lines up here now. We have Sarah here at the top. So this is Sarah with an H. And then we had Kevin, right? And we said they were both correct. So we found out and discovered today that both of them are correct. Kevin landed on his answer, and we said that Sarah she added this 1 plus her 5 to get her 6 that they done. But why would Sarah do that? What were y'all talking about? Why would she add instead of remove the pieces? What were y'all thinking? Yeah. Yeah.
Because if you start at 10 and go to 15, if you count all the way up, all the tiles make up 6.
So if I start where?
If you start at 10 and then you count up.
So 1, 2, 3, 4, 5, 6. So it's 6 hops on the number path or number line. I know a lot of you have been using number lines rather than on the path. So this was 6 hops. But why would she do that? I don't understand. This is subtraction, y'all. Why would I add? Why would I subtract? What do you think?
Because when you add, if you add 1, you add 5, that's 5 to 1.
Okay. So you like to add better than subtract? I do too. Does it matter which one we use?
No.
No. Have you used this word this year, efficient? And which one is most efficient? So both of these are pretty efficient. It just kind of depends on which one you like to do and works for you and your brain, right? Do you like to count up or do you like to count back? But last thing I want you to talk about is why did both of them not take off the whole thing or count up the whole thing? Why did they stop at 10? I don't understand why they wouldn't just take it all off or jump all the way up. Turn and talk to your neighbors. Why are they stopping at 10 every time?
They both stop if you go all the way to the
Okay, so. Oh, yes, yes. So, again, we discovered today that, or what we were learning today is you guys were analyzing strategies to tell if they were correct and why they worked. Did you do that today?
Yeah.
You certainly did. Did some of you change your minds throughout the lesson? Yes, you did, because some of us thought at first Kevin wasn't, or Sarah wasn't right. And we all thought Kevin was right, or vice versa, but we learned that they were both correct. So you both learned to analyze strategies and explain why they're correct. Were you able to model? Yes, you were. And explain. And again, I asked you to turn and talk about why they stopped at 10 and why they didn't do that. So why did both of them choose to stop at 10? Yes.
So they would come and said not so much for them to jump.
Oh, did y'all hear that?
Yeah.
It's not so much for them to jump. And like our friend up here was saying, it's easier, right? It's easier to jump to 10s and then jump out either back from 10s or forward from 10s. So that's awesome. So I think, do we have it up here?
No.
Oh, we're pulling up an exit ticket for you all. Thank you so much for letting me come teach your lesson today. We're going to put up an exit ticket where you're going to do the same thing you learned today, which was to analyze the strategy and explain why it worked. So we're going to pull that up and you're going to turn one of those pieces of paper over that are in front of you and just write on that. Or if you want to get out another sheet, that's fine too. Do they need to go back to their regular seat? Y'all can go on back to your seats. And I will come out and pick up your unit 2 while we get this exit ticket